A very good evening and welcome everyone. I am Asmita and I welcome you all on behalf of Jamshedpur Management Association. Today we have all gathered here for JMA Talks, Transformation through Experience and Awareness. For today's session, the topic is AI for Business Leaders. For the welcome address and the introduction of our speaker today, I would like to welcome our Secretary, Mr. Amitabh Bhattacharya. Over to you, sir.
Thanks, Asmita. Good evening, everyone. On behalf of Jamshedpur Management Association, I welcome Hindol. Hindol, are you there?
Hi, absolutely. Thank you.
Yeah.
Thank you, Amitabh.
So it's the honor and privilege to have you. I think Hindol has a Jamshedpur Connect, and it is always pleasure to have him here. And just to update, Hindol actually delivered the first session of JMA, not the first in real terms, but after a long time when the JMA started conducting session in 2017, he was the first to deliver a session at Center for Excellence, and it's good to have him once again on a digital mode, virtual mode today. And thanks, Hindol, for taking out time. Before I hand over the session to him, I will just briefly introduce him. Hindol Basu is a founder and the CEO of Actify Data Labs, a platform and a machine learning company. So he has 20 plus years of experience in developing data-driven solutions across financial services, manufacturing and retail. He has worked with Citibank, TransUnion, FICO and the Tata Group. Pioneered credit bureau analytics in India and developed the first set of CIBIL score in the country. He's the author of Business Analytics Application to Consumer Marketing, which has sold more than 2,700 copies worldwide. He conducted learning sessions and workshops as IITs, IIMs, and other industry forums. He is recognized as the top 10 data scientist in India by Analytics India magazine. Actify Data Lab has been recognized as the top AI and artificial intelligence and machine learning startups by CIO Review. Your Story, Silicon India, Analytics Insights, and other organizations. Hindol holds a BTech degree from IIT Kharagpur and an MBA from IIM Bangalore. I think with this powerful introduction of Hindol, I think I would hand over this session to him.
Thank you, Amitabh. Thank you so much. It's one thing which Amitabh and I share. Amitabh didn't mention, I was 1999 batch GT at Tata Steel. So I do have a very emotional connect with Jamshedpur. And it would have been good to be physically present in Jamshedpur again. I'm sure Amitabh would have taken me to either Beldi or United for a drink after it. But well, these days we have to do a lot of these things online. So thank you so very much for having me. It's an honor and privilege to present to all of you. It's an honor and privilege to be connected with Jamshedpur and the management fraternity at Jamshedpur. I have chalked out a presentation to talk about in the area where I work, which is AI and machine learning. However, please feel free to ask questions and bring your points and have a discussion rather than me just having a one-way conversation. So the topic that I have thought about is called AI for Leaders. It's a little bit of a generic topic in that sense, because a lot of things come under the purview of how leaders in an organization looks at AI and ML and how that can impact organizations. I'll also try to talk about a little bit of some of the common myths that we often hear about, or we have seen, or we see every day about AI and machine learning. And we will go on from there. So I have a little longish presentation, but I don't think I'll be able to present the full presentation. This is actually a course that I conduct in some of the business schools called AI for Leaders. So I have taken some of the materials from that course and have created this presentation, so we may just cover parts of it. Okay. So I'll share my screen. Let me know once my screen is visible.
It is, sir.
It's visible, right? Okay. Okay. And again, please don't hesitate to ask questions or share your thoughts in between. We can always take a small break and discuss things. That's the whole idea. And of course, each one of us know very little, and the idea is that we can all sort of learn together. So I just named this presentation about AI. So I just thought that before we get into the meat of things, we possibly will look at an outside-in view of AI and ML and how they're shaping organizations. So this is from a survey which was conducted by McKinsey and Harvard Business School sometimes back. And they spoke to all, mostly CXOs and senior leaders in organizations to see how AI is expected to impact their organization, how they think or how they feel or how they hope that AI will influence their organization, and in reality, how AI is shaping the organization. Now, interestingly, if you see, a large proportion of senior leaders feel that AI will enhance the functions and features of their products. Essentially, what they're trying to say is AI will transform their organizations. So AI is not for, let's just get it pointed up. So most people are saying that AI will enhance the features and functions and performance of my products. Not so much about I will optimize my internal processes, not so much about freeing up workers, not so much about reducing headcount, etc. But they're looking at AI as a transformational initiative. On the other hand, if you see where all the current projects and initiatives in AI are mostly targeted at, if you see for marketing and sales comes as the biggest one, where most of the AI is targeted as trying to increase revenue. Whereas for supply chain or for service operations or for manufacturing, it is more for controlling costs. So essentially what it tells us is, that while most of the CXOs are looking at AI to transform their organization, create completely new products, completely new business processes, most of the AI initiatives today are trying to create what we call incremental impact. Next, we also, the same survey also spoke to them about when you are trying to use AI within your organization, what is your biggest challenge? As expected, the biggest challenge is how to integrate it within my organization's processes. So I build all of this solution. I can get all the technology. The biggest challenge is how do I put it as part of my organization's process? So integrating AI within the organization comes as the biggest challenge that people speak about. So if we put all this together, what does it mean? So if you look at how organizations are trying to leverage AI and machine learning, there are a set of initiatives which we call are sort of transformative, meaning they are trying to change the business model, trying to change processes completely, transform. But unfortunately, the number of such initiatives are low, while the impact or benefit that you can get from those initiatives could be very, very high. Most of the AI initiatives today are in this bracket, which is incremental impact or incremental innovation. And of course, there is something called proof of concept, where organizations are trying to dabble into it, trying to see how it works, trying to have one project, one initiatives here and there to see how to get a look and feel about what AI and ML are. Now, if you look at these two, incremental impact and incremental innovation, while they are not the most impressive sounding initiatives in organizations, but most of the time, these are small initiatives. Each one is giving small benefit, but together they do make a significant impact. So though as CXOs look at transformation, but incremental impact and incremental innovation are equally important. Now, for example, you look at things that we have been doing in manufacturing for ages, like our Kaizen and Six Sigma, all looking at incremental innovation. Now, if you look at incremental impact, for example, there is a process which is happening today. Can we make it a little better? Or there is an AI model already in place today. Can we make it a little better to get slight more enhanced revenue, slightly lesser cost out of those initiatives? So while in boardrooms, there's a lot of discussions about the transformative power of AI, one should not ignore the incremental impact, the small impact that it can generate. And sometimes the sum of many small impact may be significant. This is another view of AI. So that is one view of AI and AI initiatives, is whether we look at transformation versus incremental impact. This is another view of AI. Now, let me give you an example of this. Now, say I have this bottle. Now, if I show you the bottle, and if I show, say, a waiter in a restaurant the bottle, both of them will make the same inference that this is a bottle. About here, we are talking about what we call human intelligence. Like I show you the picture of a tree versus the picture of a human being. And you have to say which is a tree, which is a human. So what we are talking about here is human intelligence. So there are some AI initiatives which are trying to replicate common human intelligence. For example, I show you the face of a person and the PAN card of the person, and you have to say that this is the same person. You, me, the person on the street, all of them will make the same conclusion. Now you move out to another type of decisions, which we call subject matter expertise. Now, for example, you have, say, a steel maker in an LD shop. Hello. And the steel maker is looking at the color of the flame and trying to understand, is the blow over? Do I need to blow any more or not? Now, if you show it to me, it's the same flame to me, doesn't make a difference. But if you show to an operator who has been operating LD, the LD converter for 20 years, he or she will have an intelligent interpretation of the same flame color. So here, if we have to have an AI solution that will look at the color of the flame or the image of the flame and determine whether blowing is over or not, then we are looking at trying to automate subject matter expertise. So when we look at AI and ML initiatives, it's important also for us to keep in mind whether we are trying to automate just human intelligence or we are trying to automate subject matter expertise. Now, if we are trying to automate common human intelligence, the way we have to create the data to build the solution and the way we look at implementation of the solution is going to be very different compared to where if you were trying to build in subject matter expertise. Now, if you were trying to automate or build an AI solution to create subject matter expertise, it's a very human process about how you implement it. For example, if today you build an AI solution and try to put it in Tata Steel's LD shop, the operator, the head of the department, everyone will say, who the great person are you that you can do through a algorithm what takes a person 15 to 20 years to learn. And the approach that you need to adopt to implement such solution is very different compared to where you are, for example, trying to say, you look at the picture of a person and you look at the picture of the person's ID card, and if this it's the same picture or not. So this is another background which is important for us to have in mind. On the other hand, if you look at how AI and ML solutions have traditionally been used, people have initially used it for what we call as insight generation. Can we use our solutions to extract intelligence and just present that intelligence? For example, whenever there is iron ore coming from Noah Mundi, there's a problem in phosphorus. This is what we have seen in the data and we present it. Then we move on to, we create recommendations which are provided to a human being, and then the human being takes the action. And then you move on to a situation where even the actioning is being automated. Now, from between here to here, there's a big leap, not only in terms of your solution, your accuracy of the solution, but something called faith. How much faith can people put on AI? And there are some other issues around how you look at ownership and responsibility. As you all know, sometimes back, there was a big air crash of an Ethiopian Airlines plane, and it was because of a sensor going wrong, and it was not allowing the pilot to take control of the flight path. Now, therefore, who is responsible for it? So there are a lot of questions which come when you have to leap AI from this to this. So this is some background that I wanted to establish before we go into how leaders look at AI and ML. These are some typical machine learning problems that we look at. Maybe I'll just skip this because this can take us some time to cover. If any of you are interested, we'll come back to it. What I have tried to do here is, for all ML problems which may come up, I've tried to categorize them into these buckets. And more or less, 90-95% of ML problems fall into one of these categories. And that really helps business leaders to know that now I have my team who is solving problem of this category. So therefore, how will I evaluate the solution that has been built? So it really gives a sort of mind map for a leader to see that if this is a given problem which my team is solving, which category does it belong to? And therefore, how should I know if my team has built a good solution? Okay. These are a few interesting things, and I was talking to Amitav the other day, and he also mentioned that. So maybe I thought that I'd put a slide on some of the common myths that we hear about AI. One of the most common myth, and this is very, very common across countries. I mean, even I have presented in US, I have presented in Europe. It's a very common myth, which is what is required for AI to succeed. Now, 90% of times when you see what takes AI to succeed, you will hear technology, you will hear complex algorithms, all the maths, etc., etc. However, what really makes AI successful, and that's like the heart of the AI, is data. Because AI is nothing but something that you create to extract learning from data and apply it on data. Now, if you do not have enough data, right data, diverse sources of data, and quality data, you will never be able to build a strong AI solution. For example, if you look at today, to build a solution that will look at a simple thing like a review that you have written in Amazon, Flipkart, wherever, and extract what is the sentiment of the review. A very simple problem, a very commonly solved problem. That is it saying good things? Is it saying bad things, etc.? What you really need to do to build that model, most students who are graduating from an engineering college today will know how to build that model. So now if you see that model, the strongest of such model is still coming from Amazon and Google. The reason is because those guys have the biggest and the most diverse data set, which we also call corpus, on which they have built the model. So to succeed in AI, an organization doesn't have to look for anything else but just to look for data. If we have the best data, the most diverse source of data, we will be able to build the best AI. You can always find the technology and the people who can build that solution. But what you will not be able to find out is the data which is required to build that solution. So data is pretty much the heart of AI, not technology, not algorithms, not sophisticated maths, etc. The second myth that we often hear is AI means transformation. If we have to transform my business, if we have to transform my business model, AI will help transform it. But the point is, AI per se doesn't do anything. It all depends on how we can reimagine our business. And in that, there may be pieces in our imagination which can be filled by AI. So the key to transformation is not AI. The key to transformation is our ability to reimagine our business. And in that, there may be pieces which get solved by AI. So it's like where do I go and if I have a good car or not? Having a car doesn't mean I'll be able to go somewhere. I have to know where I want to go, how the route that I will take. AI is just like the car. The other is, now, when we look at particularly AI and machine learning models, the first question is how strong is the predictive power? 95, 99, 98, and this we have learned from school, anything less than 90% doesn't sound good. But the point is, the business value of a model is not determined by that percentage accuracy alone. It depends on how you will use and what are the costs of your errors. We may not have a lot of time to delve into it in detail, but it's important to understand how will it use and what are the costs of a false prediction. As they say, the false positives and the false negatives. That completely determines what is the value of a model. Sometimes a 70% accuracy model may be good. Sometimes even a 95% accuracy model may be bad. Fourth, if we have to say, for example, you are the technology head and someone in your team comes and says that I have solved this, I have built this AI model, I have used regression. Well, regression is something simple. You can even do it in Excel. Another person comes and says that, no, I have used deep learning, and deep learning sounds very cool, and it is very cool, and it is latest. Now, it's important to understand that most complex algorithms, the state of the algorithm, will not necessarily give us good result. The biggest reason for that is, for that algorithm to show its true power, you may not have that data to support it. So in many cases, a complex algorithm is often counterproductive. It gives rise to what we call is overfitting. You, on a small data, you learn from that data so much, then you go to implementation or real life data, it doesn't work. So in those cases, a simple thing like a regression may even be better than a state-of-the-art model. The fifth, and this I'm telling you because many of you are part of a Tata Motors, a Tata Steel, Tata Power, some of the larger organization. And you often will see vendors coming up with cool solutions around video analytics, image analytics, speech analytics, various cool solutions. And we feel it's very cool and it's possibly the best. Now, one important thing is that today, for many, many use cases, everyone uses what we call our pre-trained models. Now, I'll give you an example. So there's a solution which looks at the video of a person who is exercising. And this is a solution which my company, we have built. I myself, my team has built. So this is a solution which looks at the video of a person exercising and looks at how many times, it counts how many times you've moved various body parts, and therefore it calculates what is the approximate energy that has been burned. And it has various use cases around health, around insurance, wellness, all of that. Now, this sounds very cool video analytics. From that, you can find you're tracking in real time how many times your hands have moved, or your legs have moved, etc. Very cool. Now, if you see what is at the back of it, at the back of it is what we have is a model, is a pre-trained model, is a model which is given out by Google. It given a image of a human being, it tracks the XY coordinate of 17 body points. And once you have the XY coordinate of 17 body points, and you have it in a time series manner, like each second, you can calculate how many times it has moved, how frequently it has moved. What is being used at the back is a very simple regression on top of it. Because the point is, today for many of these use cases, no one has that corpus of data to build that strong model. And there are very few companies which have that corpus of data to build a strong model. And various people, and there's nothing wrong about it, various people are using those pre-trained models which are available and fine-tuning them for various use cases. Now, if you have to really build a differentiator here, you can really do it if you have that corpus of data. If you have hundreds and thousands of videos, and in that video, you have said that in this video, I see this person is moving his right hand 10 times, left hand 12 times. If you have that data with this annotation, then yes, you can build a real differentiator, a model which is better than Google's model. So it's very important to understand it. In fact, 0.5 to some extent goes back to 0.1. 0.5 exists because, unfortunately, in the world today, there is a data monopoly. And you can build such strong models only you have the data. For example, Tata Steel has hundreds of years of steel experience. If we have the data, possibly Tata Steel can build the best model on blast furnace of operational failures, blast furnace operational parameters, etc. I mean, as many of you know, POS data from POSCO is kind of doing a lot of that stuff. So essentially, in this mental frame of things for AI, so this is a sort of mental frame that I use. So at the heart of this is the data. And then everything else that is needed to leverage or to create AI sits on top of this heart. So as a business leader, if we are looking at AI to transform our business, we need to look at, can we get a data which no one has? That is the real transformative power. If we get a data which no one has, then we can always get someone to build the solution to leverage that data. So the real push or the real endeavor is to get this center, is to get a source of data which no one has. Maybe I'll just take a pause here. Are there any questions or comments from any one of you before I proceed? Okay, if there's nothing, then I'll just get going. So this is a framework that I use to look at what is needed to drive value or business benefit out of AI. As I said, we may not have the time to go through each one of these 5 blocks in detail, but I'll try to touch upon at least the important ones. The first is reimagining products and processes. And this has nothing to do with AI. This is about our understanding of our business and how we can create a new business model or a new product or a new service. And in that, while creating that, you may say that if this piece would have been done, I would have been able to do it. That is where AI comes in. For example, you as an auto insurance company, say there is an accident. You want to, or maybe say you are an auto insurance company even before accident. Say you have people who are driving. You say that I want to understand your driving pattern in real time. And if you are a disciplined driver, you will have a much lesser premium. If you are a little energetic driver or a little experimental driver, your insurance premium will go up. No, I have to know how the person is driving in real time. So how do I know it? Can I fix something in the car, which Tata Motors and many auto companies are doing, which is the onboard device. Now you may say I have to, then if I have to get a new customer who does not have the device, I have to ship the device. That's a problem. I don't want to get this device because it sort of increases the cost as well, because this device has a cost associated with it. So can I use the smartphone to do it? Now, then after this imagination comes from the business head or the business leader, then the AI team comes and sits that can I get him or her what he or she is looking for through an AI solution? But without that reimagination or without that imagination of the business process, without the imagination of how my product or how my process or how my business model can be transformed, AI is just something which is just an academic project. So that is one of the most important aspects of leaders, to see how I want to reimagine my business model, my product, my process, and then to find out, in order to do that, there may be certain things which AI can help me address. But without that reimagination, AI is of no value. The next is the data. Now, if I have understood that this is where in my business process I can put AI in, do I have the data for building the solution? This is again the most crucial piece, because as I said, without data, you just can't build it. Do you have the data? And even at the next step, do you have a data which none of our competitors have? Do we have access to some data which competition does not have access to? That is the point where we can really build differentiated AI solution. The next three are more easy. How do we look at benefits? There are some more structured way of looking at how do we look at benefit of all of that.
But why is it slow?
Mostly the benefit estimation becomes important for the incremental solution, because if it is transformative, well, the benefit is on your face. You don't have to have any tracking to know what is the benefit of creating a completely new business model like an Uber or someone else, Airbnb, whatever, all that legendary stories. But if you are looking at more incremental AI solution, it's important to understand how we will look at or how we'll estimate the benefit of the solution. Then, of course, technology is important. There is technology infrastructure which is needed for building the solution and integrating the solution. And last, there are humans. Now, humans come in various forms. There is one type of humans who will build the solution, which are all the data engineers, data scientists, the tech experts, all the geeks, etc. That's one part of the human. The other part of the human is people who will adopt it. Let's look at the example of what we were talking about, automating how or having to know when I should stop blowing in my LD, or when should I stop adding limestone to my LD, because I know that every time we add excess limestone in the LD. How do I know that? So now there are humans who have to use the solution, humans whose lives will be impacted by the solution. And it's very important to understand how we will handle the change management. Now, yesterday, if a person was using his 20 years, 15 years of expertise for doing something, and tomorrow you're having an AI solution to it, how do you handle that change? There are a few others which are around, maybe not so much in industrial, but a lot in consumer businesses. Now, how do you look at data privacy? How do you look at sensitivity of data? Now, for example, till now, no one says that. Say you are an Amazon and you are using my data as a customer to build your AI solution. And that solution or that intellectual property is going to give you incremental revenue. So shouldn't I own a piece of that? Because that is my data. I own my data. So data ownership is becoming a very intensely debated topic. In fact, in Europe, people are asking about that consumer companies should give customers a way to forget. For example, I want Flipkart to forget every data that you have about me. I just want that right as a consumer. So that's one interesting piece that may emerge, because you are creating wealth out of my data. I'm not getting a share of it. The other interesting is explainability. Now, explainability is important because particularly when you are having an AI solution which is automating a subject matter expertise, the subject matter expert wants to know that if you have made a recommendation, what is the reason? For example, today, the head of L or the operator in the LD converter says that there is a tinge of orange. I'm looking at the tinge of orange. Now here you are saying that blowing is done. What are you looking at? What is the explainability of the solution? Similarly, say you have created a solution to automate. I had tried to create a business on that, which I failed, which is to look at chest x-rays and to identify if there's an anomaly in the x-ray. Now, you may create a recommendation for the physician that this looks like is an anomalous x-ray. But the physician will say that, I want to know what are you basing your conclusion on. When I look at an x-ray, I see this part is dense blank. The lower bone is carved upwards. Are you looking at the same things? So there's an entire set of solutions that people are looking at to see how we build explainability on top of AI models. So these are some of the important pieces. I'll try to at least cover the first two pieces to some extent, and then we'll see if time permits, we'll cover a little bit of the other three pieces. Now, this is about how we reimagine products and processes. Now, this is looked at a little bit from a customer or a consumer industry, but it applies similarly for manufacturing and any other industry as well. So one of the important aspects of reimagining the process is how do we look at the user journey and how are people using my product, and how can we change how people are using my product. For example, simply if today I'm supplying a cold rolled coil to Maruti for auto body, how are they using my product? What are the steps? And in that journey, are there some aspects which I can address where I will make that journey easier, smoother through AI? So that's one of the, for example, sorry, go ahead, please. Okay, so maybe there are some tests that are performed as soon as the oil comes to Maruti. Can we have some very inexpensive inbuilt sensors that can do something? I don't know. I'm just thinking completely as a layman, which through LoRa network gives me maybe the strain, the surface quality, something, which is a test that the customer has to perform, and I have him not perform the test. So it makes the journey easier. Similar, very closely related to the first point is identify user experience and what are the pains and frustration people have about using. For example, I have to fill up forms. For instance, if I am applying for a loan, I have to fill up my PAN number in 3 places. I have to fill up my Aadhaar number in 1 place. Now, if I am having a video chat, I just show my Aadhaar card and my PAN card. All of that is done by a solution. I don't have to do it. It addresses a customer pain point. The customer does not have to write the number thrice. So these are simple cases how we can reimagine processes. And then you can ask a technology expert to find out, can we have a solution that can do it? And it is also important to create various mock-up processes where you see how people are using it and therefore how you can reimagine. Another important aspect, how do we integrate data capture as any part of our process? Now, going back to the first principle, that data is the heart of AI. Now, one aspect of reimagining processes could be just that I want to capture more data. Today, I do not have data about some things about the customer. Can I somehow capture that? For example, say you are a banking app and you want to know if I have a office job or I have a sales job which involves moving around. How do I capture the data as part of my business process? I have an app which the bank has an app which I use. Now, from the app, can I capture location? And then can I do something with it? So at every step of reimagining the business process, it's important to see, is there an opportunity of capturing a new data which I have not been capturing? So many a times, reimagining processes also involve the opportunity of capturing a new data which I have not been capturing. Because if I can do that, I can use the data to build an AI solution tomorrow, which can be a differentiator. Now, another interesting thing about AI, which is we always, you will see most, you must have gone to various websites for various shopping, banks, insurance companies, etc. And they will say AI-powered chatbots. Now, the best AIs at the AI solution is the one where you as a customer or a user do not even understand that there is an AI. The best AI-driven chatbot is where the company can tell you with confidence that, no, there is no AI, there's a human sitting. And you as a user can't even differentiate between an AI and a human. So the best AI are those which remains hidden from the user and which works at the background. Okay. Now, there are a few other things which we need to look at when we look at reimagining the processes. First of all, is it feasible or not? For example, you may want to just build a solution which looks at the face of a person and say, what is the approximate income? Nice application. You can, as a business leader, there are 100 applications that you can think about this solution, but is it feasible to build? Next is, what are the failures? Now, one of the important aspects of AI is always that sometimes it will fail, because The whole idea of this is predictive in nature. So, and as the old saying goes, no model is perfect. All models are erroneous. Can we live without error? Now, when that error happens, what is our failure addressal mechanism? How will I address the failure of the AI solution? And sometimes this can be very costly. This can be things like accidents. For example, if you are building a solution like we were talking about earlier to differentiate between a human being and a tree and a lamppost, and you want to use the solution as part of your, say, your driverless car. Now, if there is a 0.001% error where you misinterpret a human being as a tree, because trees can't move on the road, human beings can come from the pavement to the road, you will get an accident. So what happens when AI fails? What are our modes of addressing that? The next is scalability requirements. Now, many a times, most AI initiatives are still, though possibly not in our organization, in some organizations, they're a little bit like college projects, nice projects someone is doing. And many of them work very well in a project mode. Now, can they scale? What are the challenges that I will face if I want to scale it when millions of people are using it together, thousands of hits coming to it? Of course, there are ways we handle it, but one needs to be cognizant about it. Identify integration points with other systems. Now, you have an AI solution that will work with 10 other solutions, will work with your ERP, will work with your CRM, etc. How will it get integrated? Important point. How do you know the correctness of your AI solution? Now, again, let me give you an example. Say you are predicting if, say you are predicting if someone will buy a product. And some cases your predictions, of course, are going to be wrong. Now, how will you know your predictions are wrong or not? So say someone comes to your website, you say you give him an offer that you want to buy this. Now, the person doesn't buy. Yes, most people will not buy. Maybe 1% people will buy. Maybe sometimes people will at least read your whatever you have written, whatever is the offer, they will scroll through. That is sort of a proxy feedback that your recommendation or your prediction wasn't completely wrong. On the other hand, regulatory concerns, like for example, it can be a safety concern. Maybe you had a set of sensors and models, etc., to find out if there is gas leakage. Now, say there is a 0.1% error and there is a gas leakage and an accident happens, someone falls sick, someone dies. What are the regulatory concerns? The regulator will come and say that, why weren't you monitoring? Now, we will say that we were monitoring through an AI model. Now, what was the accuracy of that? This, at least in most markets, and this has particularly happened in financial services. For example, people have this algorithmic trading. People have model-based decisioning. Now, say you make a completely wrong investment decision. So, of course, the regulator will want to know the AI model that you are using, how have you benchmarked it so that you can let it make the decision. The last is the dehumanizing of processes. Now, for example, if someone is in distress, maybe someone doesn't want to talk to a chatbot, someone wants to talk to a human being. So how do you look at some of these more softer issues of AI? Maybe we will go on to a little bit of data. So as I said, data is pretty much the heart of AI. And when we look at data for AI, and it is important to have that mind map, there are two types of data which are involved. One is the historical data, which we will use to build our solution. And then there is data on which we will apply our solution. Now, for example, let's say I'm trying to build a model to predict failure of an equipment. So I have to have the historical data that I will use to build my model. So that is one type of data. And then when I implement it in real time, I need the data of the various sensors to implement my model. So both of these two types of data are important, and we need access to that. The other important aspect is data quality. Data quality itself is, again, something where I take a complete course on data quality. As I say, data is our best friend and data quality is our worst enemy. So how do we look at data quality and how do we address data quality? This is another very foundational block of AI. Maybe we will go a little bit to some of this. This is, we'll look at how do we estimate benefits. And as we were talking about, benefit estimation becomes more important when we are looking at incremental impact. And this is a very common framework. I'm sure you are using this for all your various Kaizen and Six Sigma and continuous improvement processes as well. So if you have an AI solution, it finally impacts a set of business KPIs. And those business KPIs impact your cost or revenue. So it's important to understand this translation and to quantify what is the rupee benefit that I am deriving out of my AI initiative. A simple example, I mean, I'll not go through all the calculations of this. Say you have this is a simple crusher. Say you have this crusher and you have built a model to predict when this rubber linings. These rubber linings are very important for a crusher because once it's running, the temperature goes up and the rubber lining melts and you have to stop it and change the rubber linings. Now, if you have built a model, it may so happen that this predictive model is just changing what was your preventive maintenance schedule to an ad hoc maintenance. Sorry, there was a little bit of problem with my. Hello. Hello.
Yes,
Yeah.
you're audible.
Hello. Hi, Ashmi. Oh, okay, perfect. Sorry. Yeah. So what? Maybe I just repeat a little bit. So this is a very simple example which I use to illustrate how we look at benefit estimation and how we must look at all the dimensions which impact the benefit of an AI model. Now, this is a simple crusher which is used to say for any grinding activity. Now, this contains this rubber linings, and when the temperature goes up, the rubber linings melt, and you have to change the rubber linings. Now, of course, you have all the sensors, and you can build a model to predict when
this is going to fail. Now, when you implement the model, it may so happen that it is just changing your schedule maintenance to a ad hoc maintenance regime. But your number of hours of downtime is not reducing. So you may have a model with a very high accuracy, but it may not give you benefit. So it's very important to see my KPI, which is my number of hours of downtime, cost of ad hoc maintenance, cost of planned maintenance. How does all of this KPI get impacted by how I use the model? And that really gives us an idea of benefit estimation. Maybe I'll not get into a lot of this technology. I'll just go through one slide. This is what I call humans. And this is, I discussed because oftentimes we see young managers want to understand, or even leaders want to understand, that if I have to build the skill set, what are the skill sets that I need? And one important aspect of a good AI skill set or a good AI analyst is that person by definition is multi-skilled. So you need to have a good understanding of the business, a good understanding of the maths and quants, a very good understanding of the data of the organization, understanding of technology, and you also need to be able to handle some of the software aspect, change management, project management. How do you communicate AI to business leaders? Of course, it is not possible to have someone who is good at everything. So usually, you may have a person who is good at any one of them. And then the person usually must consciously pick up some of the other skills. Because if someone is not slightly well-rounded, it's difficult to address needs of AI in most organizations. So maybe with that, I would just close and pause if there are questions from you, and it would be good to discuss questions and your views. Questions, comments from any one of you? Hello. Go ahead, Mr. Hussain.
Yeah, only I'm saying that the wonderful session you have given this, basically the people who are not really having the technical background, but they are also understanding about the artificial intelligence. So I think some of the questions we are getting in the chat box. So I just request the moderator to.
Yes.
Yeah.
Yes. I'm able to see them as well.
Yeah.
Yeah, I'm able to see that as well. So there is a question from Nimai Chandra Gorai. Yeah. How do we include first principle model with AI? Now, if you see, when you build an AI model, as we said, we start with data. Now, what is first principle? First principle is, for example, I know if force will increase, or if the stress on a person, on a machine component increases, the strain will be higher. Or if the lubricant level is lesser, the sound or the friction or the temperature will be higher. So these are first principle that we know. And these are more important when we are building an AI solution for engineering use cases compared to more customer use cases. Now, when we build these models from this data, there is a step which is involved in between, which is called feature engineering. What you do is you try to create these features or variables from the data, which will be used as inputs into your AI model. If you look at AI models, there are basically two types, or maybe three types. There is one which are all these feature-based. They take these features or inputs, and you use them for building the model. Then there is another particularly the deep learning family, which does not need any of these features. Now, when you build an AI model, these features are all coming from your first principle model or your first principle understanding of the process. Like if lubricant level is low, temperature will be high. Now, there is another aspect to it. Remember, we spoke about explainability of your model. Now, when you are trying to implement your model and you are saying that I think the temperature will go up, it is important for you to also give that explainability to the user, saying that because there is a 10% dip in lubricant level. So now, to understand because of which feature you are having a recommendation that temperature will go up is explainability. And these features have to come from first principle understanding or first principle models so that they make sense to the business user. It's simple. If you see a person who has come to a car dealership, and we use this every day. If you have a model which says that pitch a high variant of car to him, maybe one of the variables is you look at which car he's already driving. If he's already driving maybe some cars, a Honda City or Mercedes, then pitch a very high variant of a car. So that is how first principle thinking comes into AI models through your feature engineering or the features.
Mr. Basu, can I ask a question?
Please.
Yeah, so have you come across any situation whereby, say, for a solution, different models are there, and say model 1 has accuracy of, let's say, 95% or 96%, and is not able to do good prediction, but another model which has 60 or 70% of accuracy is able to do better prediction. Have you come across any such situation? We have come across.
There could be. There could be. Now, it depends on
how
what
to
you call
believe
accuracy.
on the accuracies.
No, it is not accuracy. It's like, now let me give you an example. When you are building a model and you are looking at accuracy, now how do you calculate accuracy? Whatever is the ground truth and whatever you have predicted, what is the difference? That is accuracy. As simple as that. You have predicted that there will be a failure, and in reality there is failure or not failure. The difference of that is accuracy. The smaller is the difference, the more accurate it is. Now, what it does not look at is what are the cost of the difference. Now, one case, you are predicting that there will be failure, but in reality there is no failure. And the other case, you are predicting that there will be no failure, there is no failure, and in reality there is a failure, and the other way around. Now, when you calculate your accuracy, you are giving the same weightage to both of these errors, and you are coming to a 90%, 95% accuracy. But your costs may be very disproportionate. Now, if I predict there will be a failure, and in reality there is no failure, maybe the cost is very small. On the other hand, if I predict there is no failure, and in reality there is a huge failure, the cost may be millions of rupees. So once you take this cost into account and you take various errors and associate a cost to errors, then you will see that instead of that 67% or 70% versus 90%, if you compare this rupee of the two, then you will still get whichever has better rupee is a better model.
So we have, I hope that answers his question.
Okay. So there are a few more questions which are. Thank you so much. There are a few more questions. I'll go through them. There's a question from Ms. Shivani. Ms. Shivam Rai on HR and moral boosting of employees in the shop floor. Now, of course, humans are one of the most difficult things for any of this kind of models because humans are most unpredictable. They do not follow the laws of physics and chemistry, right? So how I will behave in a certain situation versus you will behave, how I will behave on day one, how I will behave on day two can be very different. So building things which involve humans, those customers, employees, whatever it is, whenever there's a human element to it, is more difficult and accuracies are relatively lesser. Now, there are case studies which, of course, in the area of HR analytics on various aspects of HR analytics. Now, there are cases, so traditionally, it has always been based on what we record as the data. For example, performance, absenteeism, things like that, which are easier to quantify and which are recorded in systems. And we have been building models to see if we can correlate that. So, for example, there have been a lot of work around trying to see the profile of the person and trying to find out whether this person will be a good performer. There has been use cases around how do you say the employee will be a good performer. How do we look at absenteeism? What are the factors which go into absenteeism, etc. Now, for the more softer things like morale, like what is my level of commitment, etc. And as an HR leader, you will know most of this has been part of what people in psychology has been doing. Now, can we create proxies for that? How do we create proxies for various, is the person motivated? Now, what is the proxy for motivation that I will build a model to predict? Now, building these proxies becomes the biggest challenge for this. Now, how do you build it? So one of the ways is the traditional way is the various types of psychological questionnaires to find out levels of motivation, things like that. And are there other activities that people can use? There have been people who are trying to look at from facial images, can we see if the person is happy? Again, these are all in the realm of experiments. So to have good case studies on HR analytics beyond the common ones like performance, absenteeism, etc., it's important to see how we can convert this softer people things like motivation, like feelings, like am I feeling depressed? How do I convert these to data? For example, I had one use case where one manufacturing company, they had this sort of smileys. If you feel happy or if you do something, you put a smiley somewhere. So maybe use that to find out. So that is what is the biggest challenge. Then there's a question from Mr. Manoj Kumar on how to check data quality and sufficiency for your analysis. This is a very, this is a little bit of a technical question and will ideally need a little bit of more time. So ideally speaking, data quality is a very touchy topic in the sense that data quality depends on the usage of the data, how you are using the data. For some use case, the same data may be of okay quality, acceptable quality. For some use case, it is not of acceptable quality. So before we perform any model building, it is very important that we perform a deep dive of data quality. And there are a few ways of looking at it. So one of the most common ways is missingness. How many cases are some of your data missing? Missingness is a key indicator. Then we look at some things called data correlation rules. Like, for example, if you know that, for everyday example, if you have been charged the credit card interest, then either you have paid late or you have paid partially. Otherwise, if you have paid on time and you have paid in full, you can't be charged interest. So if you have an interest charged column, and if you have the payment date, payment amount, there is a relation. Is it adhering to the relation? For example, a person will, and this is a very common error that happens. In all cases where people are entering data, you will see that they enter something as 1/1/1990. Now you can find out that and see if it is a valid date. Sometimes people enter 15th August 1947. So that is on quality. Now, do you have sufficient data or not? That is a little bit more, even deeper analysis. Now, you have to understand that with this data, going back to the question that the other person was asking, that is 90% accuracy, 70% accuracy, you have to explore a little bit to see what is the quality of the model or the accuracy of the model that I'm able to build with this data. And does that suffice the use case that I have in mind? If that does not, then you do not have sufficient data. So it is by definition a little iterative to know if you have sufficient data. There is a question from experiment fail in predictive maintenance if you have adequate knowledge of the machine. So Amitabh is asking how to identify condition indicators which can give early indicators an equipment is going to fail in predictive maintenance if you not have adequate knowledge of the machine. So of course, the one way of looking at all of this type of predictive quality, predictive failure problems is, one is you use the power of the data, which is if you have enough historical data where you have data for all sensors and events of failure, just from the raw power of the data are you able to find out. That is one where you forget first principle, you just close your eyes, use the power of the data and see if you are able to do it or not. But that leaves you with the problem of ownership of the model. How do you convince people that you have built something which is of use, which a subject matter expert or an operator who is operating the machine for so many years less? To do that, it is advisable that we take the implicit knowledge or the knowledge in the head of the subject matter expert and try to convert it to features. Maybe we have already done that as part of the data exercise, but to correlate with the subject matter expert's expertise, which comes through these features that we will build.
So the next question is by Mr. Rahman.
Yeah. What are the prospects of load forecasting related to power generation using IIML? Is it still process of predicting the future with the trends of the past? Yeah, see, this is one important aspect of IIML solutions is that you are still dependent on past data. You are still dependent on past data to predict the future. You are dependent on the past patterns. But some of the things that we also look at is, one, we look at if are there, for many of these use cases, there are pre-trained models which are there, which are sort of generic models. Of course, if your trend in the future is not going to be very different from the past, the model which is built on your data will work better than the pre-trained models. But you could also use the combination of the pre-trained model, which is maybe for all GE equipments, GE gives a model. For all, say, Westinghouse equipments, Westinghouse gives a model, or whatever. So we can use that and our model together, and we create what we call ensemble models. We use a combination of that. So that is one possible approach. The other possible approach is if we want to run some amount of simulations. Now, if we know from our models that these are all the components are going to work in this way, can we run some simulations and try to find out what can be some of the extreme scenarios, the two standard deviation scenarios, which may occur in the future. However, the models underlying the simulation are still based on your past data. So there is still that trend which is being captured by the model. So as I said, one of the key limitations of all AI solutions is they are built on the data. So they are as good or as bad as the data on which they are built. So if the other third approach is, can we create what we call as a consortium data? Meaning, can we have someone who is collating data from 10 different power plants and building a model? Now, of course, the question is, why will 9 of the other power plants share their data? So somehow building such consortium models is another way of looking at it. And when, say, a GE or any other of the bigger equipment providers build their model, they try to always build that consortium model because they try to put sensors everywhere, collect the data from everywhere, and build a consortium models. And that is where they get an advantage. So therefore, their generic model or pre-trained model and the model built on our data, ensembling them together or putting them together in some way could be a possible solution. Don't know, Mr. Rahman, if I've addressed your question.
Thank you for your response and for the wonderful session. Primarily, I was interested that as a power generating entity, how people can look up at the load on the demand side, can predict, and based on that, maybe they can modulate or regulate their generation. So primarily, that was my question.
Right. So that will have to be based pretty much on past data. When I can look at the loads of various past data based on load. And the point is, you can go, if you are looking at that, and some of this work was done after the California power crisis. I forgot the name of a couple of the researchers on this. There was a researcher somehow, some Siddiqui, I've forgotten his name. There's a lot of research which happened after the California power crisis, where instead of forecasting based on past trends, they went a little deeper, saying that, can I look at the demand of power from each of my power consuming entity based on their characteristics? For example, if it's a simple house, number of bedrooms, if they have heating, if they have a pool, etc. If it is a factory, type of factory, size, etc. So, and then I know that these are the granular power consuming units, and I can predict at that granular level and aggregate it together instead of just doing a trend forecasting. That was something which was done a lot after the California power crisis. You may try to see if that helps in some way. Instead of doing it at an aggregate level, do it at smaller unit level and sum it up.
Thank you, sir. Thank you very much.
Thank you.
So the next question is from
Nishit Kumar Sinha, right?
Right.
Right. So if you see robotics, essentially robotics is like a overarching thing. And for example, robotic process automation, etc. These are, and again, AI, ML, robotics, these are all names, and consultants and technology companies put names to also make money. So the point is, at the end of the day, we have to see what it does. So say, if I have a robotic solution. So one of the example of a robotic solution is that, say I have, you see my video, I show you my PAN card, I show you my Aadhaar card, you read all the information, you read my names, you see my picture, all the 3 pictures match, and you say it's the same person. This is a robotic use case. Now, what is happening underneath? Underneath, it's nothing but 3 or 4 AI models which are acting. So a robotics is like a term which is used to encompass many of these. For example, a simple robot which has to identify if there is a, say, on a hot surface, if there is a say, strain or a scratch, then it has to do something on top of it. What does it involve? It involves a camera which takes the picture of that surface, then a machine learning model which predicts if there is a scratch or not. If there is a scratch, then signal goes to the robotic arm, and the robotic arm does something. So these are all combinations of various AI solutions, and this comes back to a little bit your process imagining. If you are imagining a robot, then There are various things that the robot is going to do. Now, for doing some of the things, you may need AI. For some of the things, you may just need an actuator and a sensor. So a robot essentially is a set of sensors, a set of intelligence, which is a few AI models, and a set of actuators for doing something. So it's like, again, a robot is a very good example of reimagining a process. But some of it is being done by an AI solution. Okay, there is a question from Mr. Subrata Ghosh about how about auto feedback and refining the model. Now, any model, so, and again, this is a little bit of a sort of hype that goes on called self-learning model. Now, what is self-learning? So, if you have built a model with some data, you had a set of Y, you had some data, and you have built a fx to connect the Y and the x's. Now, whenever you are getting fresh data, you can recreate this f. So, auto learning, feedback loop is nothing but how you are recreating the f and how frequently you are recreating the f. Now, to recreate that f, you need your x's to be updated and you need that y to come in updated. So how frequently can you capture what is the actual outcome? What I was talking about, you have predicted something, but what happened in reality? How frequently you are getting that? And then there's a third thing. You also have to put some guardrails. Now, say something happened on a very off event. Now, you should not use it to fine tune or to redefine your f. Now, how do you put those guardrails? There are, of course, very simple ways of saying that if it is a one-off event, or if it changes the f2 drastically, then don't use this, etc. The simple ways. So, an auto feedback, self-learning, etc. is one, how frequently you are getting your updated x, how frequently you are getting your updated y, how frequently you are updating your f, and what guardrails you are putting to see when you will update the f and when you will not update the f. The combination of these four things is auto learning or self-learning.
I think we're done with the questions, sir. Are there any more questions? Kindly respond. Okay, sir, I think we're done. We have finished right on time. Now, I would like to request Dr. Hishmi Jamil Hussain, our JMA managing team member, to please present a word of thanks.
Thank you, Ashmit. First of all, indeed, it is a great pleasure to hear Mr. Hindol Basu. The way you have presented so lucidly, although many of us are not having the background which can understand, but the way you explain the artificial intelligence and that has created so much momentum that we have got so many questions. So thank you for giving this wonderful presentation, and we all have enjoyed this evening with the artificial intelligence, and we will definitely contact you to get more guidance that how we can make our system more efficient, more robust, and the next generation which is more focused on the artificial intelligence. And I'm also thankful to our secretary, Mr. Amitabh Bhattacharya ji, that he has guided and he has given this direction that we should organize the session on this topic. And I'm also thankful to the participant, because without the participant, we cannot think such kind of session, the way they have taken the interest. I'm also thankful to our committee members who helped in creating this webinar. So with that, I'm saying thanks to everyone and closing this evening. We will organize some more interesting session in the future. So we look forward your active participation in it. Thank you very much.
Thank you so much. Thank you so much for making me part of it. Thank you so much, everyone.
You are welcome, sir.
Bye.
Bye bye.
Thank you everyone for joining in. Have a good night.
Bye.